We got to take the air test, then we have to take our final. But the final is over even more than our air test. So finals in like.
Whoa. The air test is in. Finals. We'll get there. We got other things to stress about. All right, so what I was getting at is that when we have, I think we're better at them. We're much better than we started the year. But when you struggle with proofs, we need to be able to write proofs. All of the properties that you have to learn and know can be proven most of the time just by things that we already know. Okay, so here we have given that AB is parallel to CD and AC is parallel to BD. So I like to go ahead and mark that on here. AB is parallel to CD, and that this is parallel to that. Okay. We're asked to prove, and there was some misconception that that automatically, if the lines are parallel, then they are congruent. But that's not necessarily true. Okay. We're going to find out that this will actually be true that they are. Okay. But we got to prove that. The best method that we have for proving things congruent is by proving triangles congruent. Okay. Here's the problem with this shape. How many triangles do you see on this shape? Zero. So we are going to. You see two triangles?
Yeah. You have to make two triangles.
Oh.
Why?
No. Stop. Sorry.
So we are. Hey guys, let's get in a I'm ready to learn mindset. Okay. Okay, so some of you are visualizing the triangles without them actually being there. But yeah, that's what we're going to do is we're going to go ahead and turn this into two triangles. Okay. You're allowed to make segments that even if they don't exist. Okay. And no one can argue that CB is congruent to CB. Okay. So let's go ahead and now write the proof. So we got statement, reason.
We should make four triangles.
You're gonna prove the triangle and then you're gonna prove
Make four triangles and then that's the eighth question.
You're gonna prove the triangle.
We'll get there.
Make 16 triangles. Prove that AB is congruent to CD and AC is congruent.
So if I can prove that this
right
here.
Right under where it says the parallel mark. I don't think.
Mark is on something.
Okay, see right here where it says Geo Notes 6.3. That's okay. So somebody help me out here. Yes. Say it one more time. Okay.
Ooh, angle C. Angles ACB is congruent to angle DBC. Alternate here.
ACB is congruent to D. That's a D as in dog. BC. I'm listening.
That's alternate here.
Alternate interior angles. Okay. And again, we talked about this, but when you have parallel lines, you can draw these Z's. Okay. And the Z here would be causing this to be congruent to that. And you can make a backward Z, or actually a regular Z, for here. Okay, you can make a Z here.
A, B, C, and then
Okay. And then you can turn the paper.
The one I did is the other one.
Yeah, the one he did is the other one. I can't make a Z going this way, but I can make a Z going this way. And the only reason I'm allowed to make both those Z's is because I'm told that they're parallel, that this is parallel.
Can you go the other way too?
What other way?
Like, make a line like an X.
Go, oh, like this?
Yeah.
Yeah. We could have gone the other way, absolutely. Okay. So the purple makes that these are congruent, and the green is going to tell me that this is congruent to this. Okay. So I haven't listed which angle.
It's
BCD. And then thank you, CBA. What allows us to say that?
Alternate interior angle.
Mm-hmm. Okay, and then what?
The triangles are congruent.
Triangle
ACB
ACB
is congruent to BDC
BDC. How do we know that?
because of angle side angle.
Angle side angle. Okay.
And now you know that
Wait,
BD. Now we know that segment BD is
Hey, guy, what are we talking about? Okay. So then AB is congruent to CD. Corresponding parts of congruent triangles are congruent. And then
the other one. And you can also prove by CP.
I'm gonna search today. What if he found it himself and he deleted it?
Mark.
Nope.
So. Can you, if you're proving two squares, could you put like, instead of that triangle thing, just a square thing? Like square A, B, C, D, square to F, H.
Instead of writing the word square, can you draw? Yeah.
Are
So
you ever gonna prove it? Square?
I don't think so. Yeah. It's almost always triangles. Because really, everything's made up of triangles.
Why are triangles so important?
Because everything's made up of triangles. Yeah.
Yeah.
So you can break things down pretty easily into triangles. And
It can be, but they have.
I mean, even finding the area under a curve shape or a circle in calculus, you use triangles to get approximations. You'll see that in like 4 years, 3 years, or whatever. Okay, so that even though that's that shape, we just kind of proved that if you have a parallelogram, that the opposite sides are going to be congruent. Okay, we basically just proved that. Now, you could argue that it's just for this one, but I could draw a different parallelogram and use those 4 letters, and the same proof would apply. Okay, because the only given that we used was that these were parallel. Okay, they're not postulates, they're called properties. Okay. Yeah.
Guys, is given.
Guys.
If that's given, and we
Ryan,
can prove
stop.
that they're already equal, then why can't we just say that they're equal?
This is how.
They just make it easy.
So basically, once we have a new rule that we've proven once, then we're allowed to use that rule. So now that we've used this rule, the only thing I would say is I might on the test ask you to prove this is true. This is how you prove it. But now that we know this, you can always say, oh, it's a parallelogram, opposite sides are congruent. Okay? You don't have to, you could almost, if it was a proof where I'm trying to show something, you could go from this given to this, and your reason would be opposite sides of parallelograms are congruent. Okay? But we got to do it once, and then once it's done, now it's locked in place. Though I got to warn you that there are proofs on the test, and the proofs today would, or something like it, would be awesome for the test. Okay. So same thing. We have a parallelogram again. Is exactly the same given information. Now we got to prove that angle AC is supplementary, or actually these sets are supplementary.
What is, they're not congruent.
What?
It's written wrong.
Oh, I wrote it wrong.
This is bothersome.
It is bothersome. So can you get rid of the congruency marks and put commas there?
Wait, what? I don't know what's going on. I don't know.
They're not congruent.
So it should say, show that angle AC is supplementary, show that CD is supplementary, BD is supplementary, AB. They should be commas there. Now, something that I keep not doing, which is probably bad habit, but we should almost always put the givens in the proof.
Go into the box and write it out.
You guys are gonna I can't tell if you're gonna be confused by this proof or that you're gonna like it. Okay.
I can't.
Yes, Mr. McConnell. So like I went to Miss McCarthy for AR, and so I went up there asking her for help on the proofs, and she's like, no way.
Yeah.
Yeah, no one likes proofs.
I do.
No, even John.
All right, so somebody tell me what to do next. Nope.
Give me a minute.
Oh, wait, there you have it.
But that's a good instinct to cut it in the middle. But that's not what we're gonna do here.
We did the work.
We could do.
You use like the N and the 2, N minus 2, something. I don't know. It's minutes.
I think I'm gonna just show you.
Okay. Oh wait, don't they? All the angles are
I know what we're doing, Mr. McConnell.
If the opposite angles are congruent.
Who said that?
What?
Who said the opposite angles are congruent?
Smart.
I know.
That's
How would you do it?
But we don't know that.
Isn't it same side? Same side.
It might not be the same thing.
Oh,
If we draw out the line, we could see that.
Oh well.
Like,
Oh, the middle thing.
Same
Like,
side.
the middle-
Same side.
do it again.
There you go.
Same side as your
Yes, there we go.
Yeah.
That's
Teamwork.
Why is that?
Mr. McConnell, Maddox has the reason.
What was that?
Are you guys just chatting over there? You're killing me. Killing me. I don't care if you have it down. I don't want you just chatting. You're killing me. So you don't have to. The point is that you're not paying attention fully. Stop.
Mr. McConnell, do we then have to raise supplementary after that? That they are supposed
Well, so I wrote that it equals 180. Are we okay with me doing that? That means supplementary, right?
Yes. Or is that just?
That's what I'm doing.
Okay.
Okay.
Also, angle B plus angle D is 180.
Equals angle B.
So B plus B.
Then maybe it's bad form that I'm writing equals 180 and not then saying supplementary, but. So all you had to realize was same side interior postulate says that those angles add up to 180. Okay. Mark wanted me to extend this line out just so it was clearer to us. But if we have two parallel lines here,
Like we did on that packet.
and that this angle here is not congruent to this angle, but same side interior, when we drew them and we added those up, we saw that that equaled up to 180. And then we could actually do it the same way here, that this one and this one, because of these parallel lines, will equal 180.
So we just finished the first.
Yeah,
Wow.
that one was really different because basically we had one thing to say, is that same side interior tells us that all of those are congruent. Or not congruent, or are supplementary. Okay? So the next one.
Why is this?
So now we want to angle B.
It's not a postulate, it's a property. Yeah.
So we can prove those by whatever that property is.
This here?
Yeah.
Let's do it slightly differently.
Oh.
AB is parallel to CD. Given.
Okay. So I'm debating in my head whether to
Can't we do the same thing, but with English?
yes. Okay. So it's actually, if I were to take my first proof, which is this, then I can say what? And you know what? Let's just add it on here.
We could do the same thing and then just change the CTCTC.
Okay. Right? So what I'm listening.
So just write all the first four down.
Uh-huh.
And then write instead of A, B, and CD, we can just do what it says to do.
Angle A is congruent to angle D. And
Angle C is congruent to angle B because of CP congruent corresponding.
now the only catch here is that when I cut the triangle this way, then angle C and angle B are not corresponding. You have to say that those angles add up to that.
Because they're cut in half.
Because you cut them.
What's your cut?
So you have to say that angle ABC plus DBC,
Okay.
they're congruent. They have congruent parts that they share. So if I take a congruent part, two congruent parts, and then two other congruent parts, and combine them together,
You just got one giant.
then you have a giant congruent part.
Or you could also just repeat the steps for AB.
Or, right, and I think it would be easier to cut it this way prove that this triangle is congruent to that triangle.
Why?
Okay, and then then it's the same.
Because you're just proving both triangles are congruent, and then you just said angles. Instead of the real angle.
So that proved that opposite angles are congruent, okay, on a parallelogram. Okay, so for the sake of time, I think I'm going to skip the fourth proof, but we're going to just talk about it real quick, okay? We want to prove that AD bisects CB and that CB bisects AD. What does it mean to bisect something?
Cut it in half.
Cut it in half. So that means AE would be what? AE is congruent to. So basically what we're trying to prove is that these are congruent and those are congruent.
AE is the midpoint of AB, so it automatically proves that AE is congruent to DE. And then
So for the sake of time, we're not going to write this proof, but if you can prove that this triangle is congruent to that triangle, then by corresponding parts of congruent triangles are congruent.
Could you say that all of them are
Hold on, pause one at a time, please. Mark?
Could you say that all of them are congruent? It kind of looks congruent.
This triangle is congruent to that. This triangle is congruent to that. This side is not necessarily congruent to that side.
Could it be?
It could be, but it's not necessarily.
Which
What
side?
if it is?
Which side?
These two sides are not necessarily congruent, but these ones are.
I feel like they would be.
Okay? Yeah.
Aren't they all congruent by side angle side?
Wait, if they are bisectors, then they could, because the two angles are the same on their sides.
Well, the thing is that this angle here matches not this angle.
Yes, it does.
No, it doesn't.
It matches this angle.
But
Now, if this angle was congruent to that angle, then I would say that these two are the same.
we just proved that parallelograms angles,
Or something then.
That the whole angle is equal to the whole angle over here. Okay, so if we had that these two are the same, which we can, it would say that this is the same, and it would tilt it up, and it would make it into a what? It'd be a rectangle. Okay, Dalton, you wanted to say something, bud?
I was saying since E, since they all show E, that would be the angle.
Ryan, you're killing me today.
We already know that that's the midpoint. It says that this is like the side length, so then that would be all triangles like CED and AED. Those are congruent for my side angle side, and then same with AEC and PEC.
Okay. So, and one other thing I want to point out here is that we would use this first, showing that opposite sides are congruent, as one of our parts to this proof. Okay. So once you've proven it, you then are allowed to say it in the proof. Okay. So basically, we've been talking about parallelograms. Unfortunately, I have a little green on this, but we can go with it. What's the definition of a parallelogram? What makes it a parallelogram? Two sets of parallel sides. So that's the definition. So in a proof, if you're ever trying to prove that they're parallel, it's a parallelogram, you'd say by definition, this is what's going on. What are the properties?
Two sides of congruent.
Okay, opposite sides congruent. That's one. What else? Opposite angles. Angles congruent. What else? What do we call that? He said that this angle A plus C is supplementary. In baseball, what is it if you hit 2 home runs
Back to back.
back to back?
It's
Double the
turkey.
points.
Or in bowling, it's important if you get strikes
No, it's a turkey. If you get three.
Turkey's 3.
Yeah.
3 in a row.
If you get three, it's a turkey. Double.
Consecutive angles are supplementary. Okay, so consecutive means next to each other. Okay, so C and D add up to 180, D and B add up to 180, B and A, so forth. What else do we know?
Oh,
Diagonals bisect each other.
Diagonals bisect each other. Okay, and just to be careful, not always congruent. Okay, or not always. Let's get rid of that. I don't want to confuse this. But Mark's point that they're not the diagonal pieces are not always congruent. Is that all we had?
4 sides.
4 sides? Okay, that would be up in definition.
How do you say equal angular?
Equal angular. Equal angular.
Equal angular.
Okay, so here's the essential understanding. Okay, basically repeating what we just said. Consecutive angles are supplementary, so we just said that. Opposite angles are congruent, we just said that. Opposite sides are congruent, we just said that. And diagonals bisect each other, we just said that. Okay, and I said draw an illustration, but we're gonna move on for time's sake. But basically, you need to know those 4 things. I call you in the middle of the night and I say parallelogram. Those 4 things need to pop in your head. You need to know those 4 things. Just so we're clear, it may not seem hard now, but when you add in more shapes, it gets more and more confusing of what is what, okay? But really, I say parallelogram, you should say those 4 things. When I say square, you should say the following things when we get there. They'll have those essential properties, okay? And to Hope's point, she kept asking, is that a postulate? For some reason, we just call these properties, okay?
Why didn't you learn about shapes and
To get you ready for today.
Wait,
We're gonna- so why did it? Okay.
I can't remember shapes.
Oh, I know how to do
Yeah.
it. I don't remember elementary
Mark.
school, period.
Hey guys, we gotta get this done. So, question, unfortunately it's hard to see, but I think you can see it on yours. So it's a parallelogram. What information do we have about parallelograms that can help us solve this? Yeah. Okay, so set me up an equation.
4x equal to 5x minus 3, so
X is 3.
4x is equal to 5x minus 3, so x equals 3. So, and we got to find all the sides.
The 2 sides on the
So this equals what?
RS and QP equals 12, and QR and PS equals 18.
Okay, once you find one, you can just say the other one is 12. And what did you say the other one was?
18.
18. And once you find that one, you don't have to plug it in down there.
It's 18. 21 minus 3.
If you did not know that the opposite sides are congruent, you would have a really hard time with this. Okay. And then this is basically two problems in one. Guys, stop. Killing me today.
So large.
Okay, angle B is 114.
Angle B is 114. Okay, because opposite angles are congruent.
That makes the other angles 64.
64.
I got 66.
66.
66.
Yeah.
Yeah, that's what I got.
No, that's
Okay.
what I got.
Sorry, I was supposed
I got
Yeah.
5.
So because consecutive angles add up to 180. Okay. And then finally it says we have this parallelogram. They tell us that SU is 35. So that's 35. And that KT is 19.
That means B is 38.
So RT equals 38 because we know that's been cut in half.
SK is 35.
And SK is,
35.
well, 35 is all the way.
No. It's 12.5, I think.
What are you doing?
17.5.
25.
17. I was close.
Yeah, he was.
The whole 5
He's
off.
only off by 5.
Yeah,
That's why.
It's a lot this one.
It's a lot for a racer.
I watched too much.
All right, so I would like for us to